Hi, Brian.
Hello?
Hello? Yes, I can hear you. How are you
Yep.
today?
Pretty good. How are you?
So you're going
How are
to,
you?
do you have any past paper or you want to problem
Yeah,
solving?
we've done the past papers.
Mm-hmm.
They were pretty simple questions.
Oh, really?
Yeah. Um, I think just I just have one. I
Mm-hmm.
think. Then um
You can just share your
oh
file.
yeah, I
Yeah.
have to draw it because I
Oh,
have paper copies.
paper copy.
I
Oh,
need, yep. Um
yes, you can. Can we just go to whiteboard then? Whiteboard.
yeah.
Okay. So you can draw anything. You can draw any questions. Do you like the white background or dark background?
Oh, it doesn't make a
Doesn't
difference.
make difference. Okay.
Yeah,
Sometimes people find it too bright, so it's okay.
yeah. Um, so like, oops, what?
What is area? The combination or
Oh, vectors,
native
vectors. Like,
vector or a vector?
yeah,
A vector. Okay.
like, so
It's the sum or difference or
the forces,
the
like,
force. Oh, you're still doing the yeah. How many force in this case?
so uh,
Just
sorry. There's like a box here, a
yeah,
box, and
yeah. That's a physics problem, right?
yeah. So this is 16. Then
Yeah,
there's this,
that's the
the
degree.
gravity.
Yeah, it's gravity.
Uh, is there a gravity? Oh no, it's actually the weight of the box is 8 kilograms.
Yeah, so the condition, so this first question, right? So the weight, so you have to can we tell use W to weight? What is the number for weight?
Uh, 8.
8, okay. So that would be used in Newton, right? That unit would be
Yeah.
Newton, okay.
And what else? Oh yeah, there's a force.
Normal directional force, do you have a normal
Uh,
directional force? No?
there's a force. So if
Horizontal?
this is the
Yeah,
horizontal, there's a
horizontal, yeah.
force coming in
Ah,
at
okay, so,
4 degrees.
okay. Oh, that angle is given. Can we call it F, right? One
Yep.
is F, yeah.
And you're given you're also given that the force of the F is 2000 newtons.
Yep, so F is given, that's good, that's good.
Yep,
Any
F
other
is
condition?
2000.
Yeah, any other conditions?
No. So all you have to do is
No, no,
calculate.
they have to specify is it's in the equilibrium state or it's balanced?
Yeah, like oh no, you have to figure out it's not in equilibrium at the moment. You have to
Oh,
figure out the magnitude and
yeah,
direction of a force that would
yes,
cause the
the total
object to
force.
be in equilibrium.
Well, that is, and you are talking about the equilibrium. See, that is assuming this in this case, this object is balanced, is not moving. Okay.
Yeah, you need to. Yeah, we just need to calculate the force that would, I think, like guess put it in equilibrium. It says magnitude and direction
Of the
of a
total
force.
force, of total force.
Oh no, of a like another force, like something like this or something like that, that would put the object into equilibrium.
Okay, you have to find another force, some from
Yeah,
somewhere, in order to balance these two, right?
yeah,
So,
yeah. In order
so
to, yeah,
see. That's why that's come to my first question. They must assume that this is, although there's another force. Can we say there's another force here? Can you say it's F
yep,
or F1, or you can use different force? Can we call just? Can we just call
like,
F1? You can call
yep.
F1 because you got F here. You got F. Yes, certainly. If you can work out the total force which will
Yeah.
keep that object in balance condition. So basically, we're still dealing with this one. So we're still dealing with as a total force, where force is vectors must equal to 0. That's equivalent to say the equilibrium or balance or equilibrium. Equilibrium, right? How to say equilibrium?
Like a L, equilibrium. And yeah.
Well, basically they are dealing with equilibrium state because you can't, because you didn't say, you didn't, this is a mathematical problem, it's not a physics problem. So you have to find, this is condition. So basically this is condition you're going to use. Do you know how to use this condition?
Yeah. Yep. So in the problem is the school said you can think of any force, like from any direction.
Force. Yeah, that's right.
That puts it in equilibrium.
That's right.
And the school said it's easier to make it perpendicular. I mean, parallel to the plane.
Mm-hmm.
Like, so
yeah.
For this, you just have to.
No, you have you actually you're quite confused. So because basically when you're dealing with this problem, the first thing you have to consider is to actually dealing with to isolate object. Did I talk to you before? You can't draw the force in this way. You can only draw. Can you just rewrite this object? Can we say the mass is m, or the mass is not given, but certainly implied in this case, right? Because do you know why? How to find the mass? The mass were equal to, so basically, 8 Newton were equal to mg, right? So So if from this information, what we can say is that the W were equal to 8, and also equal to mg. Right, so G is given, so therefore mass can be calculated. The mass were equal to 8 divided by G. So what is G, do you know?
9.8.
Yeah, 9.8. So in this way, you should be able to work out the mass. Okay, so mass is given. Now, my point is to solve this problem, you have first to draw what we call the free body diagram. It's called the free body diagram. Did your teacher say that?
Yeah.
You have to draw the free body diagram.
Yeah.
Body diagram. Otherwise, you can hardly get the correct answer.
Yeah.
So basically, you separate the object, and then you will work out how many force acting on it. Do you know how many force? That is very important.
You've got
one
3.
Is gravity. You got the gravity.
Yeah.
The gravity downward. Okay.
Yeah.
And can we use different color to represent the force? Just make sure it is a force. So we use an orange one. So this is gravity. Okay. Now this force is also given, so it's in a very strange position, right? It's not. That's
is that
force,
F?
Yes, F. That's for F, right? To do that, probably I will draw that. I just indicated the direction of the inclined the surface. I probably have to show the direction, just direction, okay, just direction of surface, the green color.
Oh, yeah, that's good.
Now, another force you have to consider is that the normal directional force.
Yep.
Now, of course, in this case, and you are not sure because probably to make it balance, you are not sure. But one thing is certain that the sum of this force must be equal to 0. So the unknown force could be just opposite to these two directions. Okay, although we don't know, we need to determine the magnitude as well as the direction. Can you see? Just roughly, graphically, we just draw this. Is it probably just roughly this direction? Okay, we don't know exactly. So what can you do? So you got 3 force here. You got a 3 force here, right? Well, in this case, we don't, it just make exaggerate. Otherwise you thought it, you would think it is just normal directional force. It's not necessary. So in general case, they may or may not perpendicular to the surface. Can you see?
Yeah.
I just draw the force here. Just make sure it is not perpendicular to the surface. Okay. Of course, you can prove if you can prove that it is indeed perpendicular. That is just another issue. So in the first place, you have to assume that it's not perpendicular. Now, can we just write? Can we label them? That's how you solve the problem. This is W vector. This is a force given F, and this would be the something else unknown. Can we say because
F1?
Yeah, F1. Yeah, just call F1. Yes. So in other words, you need not only in this problem solving, you need we have to find the direction of the F1, but also the magnitude of F1.
Yeah.
So how do you do that?
You can use components?
Yes, to do that, you need to choose a coordinate. How do you choose your coordinate?
To make it easy, should we make the plane like this, the x-axis?
Good. That's good point. It's good way to do that.
Then
yes, yeah.
If you have the perpendicular.
Yes, that's like y. Sort of, yeah. Can I help you? Can I help you draw the straight line? Yeah.
I'll just erase what I get.
Because the better the diagram, the more reliable your result will be. See, so if you can bring the some rulers or triangles during examination, can you?
Yeah, I have to. Yeah, definitely.
Well, in this case, can we work out each angles? Okay, the angle is very important to work out the total force. So do we know this angle? So first of all, do we know this angle? Do we know? Do we know this angle? Can you answer me? Do you know this angle?
It's 16.
Yeah. That's exactly. That should be equal to this angle. See? So that would be theta. Can we call the theta? So this should be theta. Okay.
Yeah.
Another angle given is this angle is given. So that's for this is horizontal. Can we draw the horizontal line here?
This is in total it's 20 here, but like
I'm not asking you, I'm not asking the magnitude, I'm not asking the direction of the force.
Yeah.
So the force direction here, no, this is unknown. This force is unknown.
Oh, that one's unknown.
Yeah, this is unknown. We don't know. We probably put alpha here. Can we put alpha here? Just indicate.
Yeah.
Or probably just put this side is alpha. Can you see? I would prefer because this angle is alpha. So this angle, right, is alpha.
Yeah.
Now another issue is how about the relation about say this is although the F come from that direction, but ultimately you will notice that this angle is given. So this is the second angle. That is 4 degrees.
4 degrees.
Yeah. Can we call the alpha beta? Can we call the beta? Can we call the beta angle? You see? So I use letters. So basically theta will, of course, ultimately you will use the theta equal to 16 degrees, right?
And this is theta here.
Yeah. Mm-hmm. So theta were 16 degrees, and the beta were equal to 4 degrees?
Yeah. 4 degrees.
And alpha is unknown. Okay, so alpha is to be determined.
Yeah.
Okay, after you've done that, then it's time to pick up their components. Do you want to try?
Yep. X components first.
Yeah. Yeah, you just found their components, and they were going to zero them after you got all.
Yeah.
Yeah, I just follow you now. I just follow you to see if you can do it by yourself.
Yep. I just draw a line here just to check. So the X component is
how many X components we have taken into account?
Pardon me? Sorry,
how many X components should we should be taken into account?
There's 1, 2, and 3.
That's right. There are 3 forces. Therefore, there are 3 X components.
Yeah.
So do the Y component.
Y components.
Yeah. So you should be able, you must find the 3 components first.
Yeah. So the x component of this graph.
Yeah.
Is
What does that 9? What does this 9 mean? You want to do projection? What are you going to do with this additional 9 here?
Yeah. Let me just.
Can I use my colors? Use different color. Did you draw this way? What does it mean? It's nothing. It's meaningless. What
Yeah, that's nothing.
Yeah, it's meaningless.
Well, to find the
projection.
X,
yeah, you need to find the projections.
This one's it's meant to be perpendicular.
Yes, that's correct. Can I help you?
Yeah.
So this
yes,
you need to draw the right angle triangle here. Okay, otherwise
Yep.
we cannot solve this problem.
So that means the x component is cosine. So that's f cosine 20.
So you got the
Because
sum.
of it.
You got the sum, right? You got the sum.
Yeah, of alpha and beta and theta.
Yeah.
Plus
20 degree or 20 radian. Degree.
degrees.
Degree. Yeah, put degree here. Yeah.
Yep.
Second component.
Second component, gravity.
Yeah.
Yep. So
you also need to draw the proper right angle triangle.
Yep.
That's right. Yeah, that's right.
Yep. And do we know the angle?
Yes, we do know the angle. One of the angle is given.
Yep. This is if this is 16 and this is 74.
That's right.
So then the x component is cos 74 w. But isn't it mg?
Yeah, well, yes, well, in this case, you don't need to know the math. The reason I say that is if you treat it as a physics problem, you can work out the math. We don't need math in this problem solving. We just treat it as a force, that's all.
Yeah. So is it cos? Yeah. So it's.
Are you sure?
Pretty sure it's cos because it's
no the whole term. So this is where you have to be careful. When you put the components, yes, it's cosine, yes, cosine.
Yeah.
Now, can I help you to rewrite this properly? Okay, can we avoid use I suggest you avoid use this number in the first place. Because formula is insignificant, it's trivial. Number sometimes can be very tedious when you're doing the manipulation. So my suggestion is that can we rewrite these components here? Of course, there are third term here. The first term will be f. Oh, it's 6.
Like cos.
Yeah, that's cosine.
Theta plus.
Yeah, that's right. Theta plus beta, right?
Yep.
Theta plus beta. Yeah. How about this component? Is W time cosine sine theta. Can we just say sine theta? Can we
sine
just say
theta?
Sine theta? Yeah, simple.
Yeah.
Okay. Because you don't know, people will have to, ask, why. Then in the first place, you don't explain too much. You just put the notation in your diagram.
Oh, yeah, it's easy. Okay.
Yeah. Another thing is that when you draw the diagram, you just use the symbol. You don't put a number here. Okay.
Yeah.
If you put a number here, I just remove that. You make it the graph easier. You don't put a number here. You put the letters. Okay.
Yeah.
Now, one terrible mistake you made so far is that if I want to remind you, one of the terrible mistake you have had is that this is a negative, not positive.
Oh yeah, that's fair.
Yes, be careful. Be careful.
Yeah.
Now, how about third term?
To be. Oh. Well, if you draw you have.
You have to draw the another
Yeah,
rectangle triangle, right? You have to draw
on
another
the,
rectangle triangle.
but we do not know the angles at the moment.
Well, we just use alpha. You see, doesn't
Oh,
matter.
alpha.
Alpha
Yeah.
is unknown. We know alpha is unknown. That's fine. That's
Yep.
alpha to be determined. That's fine. Yes. So how about the third term?
It's the x component is negative f1 sine alpha.
Exactly. Yeah.
I'll just write it.
Yeah. And this must equal to 0. Do you agree?
Yep.
This is first equation. So it's equation 1. How about I just have split up. So how about the y component?
Yep. For the first one, it's actually I'll just do the I'll do the f1 first. Oh
Yeah.
no, because it's a positive. It's
Yes, you can do
f
it. Yeah.
cosine alpha,
Yeah. Yep.
minus f, like the normal f.
You don't have to use bracket. If just a single variable here, you don't have to use bracket.
Oh, this is, it's 20. And plus beta minus w cos theta equals 0.
That's right. You got two equations, right? And how many unknown in this equation?
Two equations.
Two unknown. Do you agree?
Yeah, two unknown.
So can we solve this
Is
unknown?
it? Oh yeah,
Yes. Can we solve this unknown?
Oh yeah.
Or perhaps we just solve it one by one if you wish. So how the rest of this problem solving just how to solve this linear equation, simultaneous equation. So any special strategy you can use to solve these two equations?
We're solving for f1.
Yeah.
So if we could rearrange the top equation for f1.
Yes, you can.
Try that. So then if this is equation 1.
Yeah.
So that means f cos beta.
Yes, you can put this unknown on the other side. Yes, that's good.
Yep. Oh yeah. And then second, we just, we don't need both, do we?
Well, you need two equations, both equations.
Yeah.
Otherwise, you can't solve two unknown.
Oh, we know. Oh no, we don't know W. Not yet.
We know W. We know W. Yes, we know W.
Oh yeah, we do.
We do know W. We know F. We know W. So we know F. So this, I just remind this condition we given. So we know W.
Oh, beta's the one we're solving for.
Yeah. No, not beta. Not the beta. Right. That is beta. Do we know the beta?
Oh, alpha. My bad.
That's right. Yeah.
And the second one is F. Yeah. So those are the two equations.
Yeah.
And
how to solve that equation?
You'd substitute W, you substitute F1, you substitute alpha, and you'd substitute, not alpha, beta and theta, and then you can solve you can.
Well, yes, that's
So should
principle.
we substitute?
That is a principle. You have to work out strategy. I help you to work out strategy. Okay. Do you want to?
Yeah. Okay.
So can we call this is A? Okay.
Yeah.
And can we call this a B?
Yeah.
It's C, D, and C and D. So what we can rewrite is that this equation. So basically F1 sine alpha will equal to A plus A minus B, right?
Yeah.
And F1 cosine alpha equal to C plus D. So both all these A, B, C, D are given, right?
Yeah.
Now can you solve
Or
that problem?
divide?
Oh yes, simply certainly I would choose divide. Yes.
That means you get tan alpha.
Yes, you got 10 alpha first. Yes.
Yeah. And that means F1 divided by F1 is just 1,
Yeah.
right?
Yeah.
So then
You got 10
you
alpha
only get
first.
10.
Okay, you get 10
Yeah.
alpha first. Okay. So first, just use calculator to solve the
Yeah.
the 10 alpha, and then in order to work out the alpha, that's in first place.
Yeah. Oh yeah. This is a calculator test. Yeah.
Well, yeah, it's certainly it's you know, you have to simplify the equation. How to determine F1 then? How to determine F1?
Well, if you're given sine, so you know AB,
yeah,
right? And you know
ABC.
alpha, so you could do.
That's right.
Yeah.
You can
Yeah.
work out these 4 numbers. You can work out the 4
Yeah.
numbers, right? Yeah.
So like if you want to figure out,
you can
for
use,
example, F1.
You can use any equation. Can you see? You can use any equation to solve the alpha. For example, the first equation, sine alpha will equal to sine alpha equal to A minus B divided by F1.
F1, yeah, and then
Or
you
just
just
other way
F1
around, probably
equals.
just way around.
Yeah,
just,
other way around.
Yeah, other around. It's F1, we solve R1. So you have to be quick, okay? Next time you have to be quick.
Yeah.
You have A minus B divided by sine alpha. You agree?
Yeah.
So alpha is given, so alpha can be solved from this equation. You see, this is alpha.
Yeah.
Simple, but you have to follow the proper procedure. Do you want to go through that? So first you have to isolate to draw the free diagram. The free body diagram is very important. After that, you have to write the 2 components properly. Be careful about the sign, okay? Each sign, be careful. Whether it's positive or negative. It's depending on whether they are positive or negative, depending on the whether they are parallel or anti-parallel to the XY directions.
Yeah.
I think we have done this. We have solved this type of problem several times.
Yeah.
Do you have another question?
Oh no. This is probably
just one. Oh.
Yeah.
This is a challenging one. This one challenging.
Yeah, it's the last question. There's it's only 10 questions, but this one's worth 5 marks.
Oh yeah.
Yeah. So yeah. There's nothing else really. Determine the projection. Nah, that's good. Oh yeah. That's it for that test. I'll just quickly. I don't think there's anything else in the other test because that was pretty simple. No, that's it. But I do have there are some questions on the textbook for the chapter review.
Okay, chapter review.
I was looking at the chapter. I was doing the chapter review, and yeah, it wasn't. There's some pretty good questions. There's just one question I just need to quickly find and.
Yeah, which page, which chapter?
Oh, I could share my screen.
Yep.
If you want me to
Yeah,
like.
you can share your screen. No problem. I will just stop this. Let's stop this sharing first. Okay. Did I put the restriction here? I just double check. Yeah, multiple participants share. Yeah, okay. I just choose this one. Yeah, so you can share screen now.
Can you see this?
Yep, I can see. Question 17.
Yeah.
Speed given. Still water. Swing cross river. So this is a belong to relative velocity problem, right?
Yeah.
Do you have trouble with that?
Yeah. Yeah. I was just trying to figure out. So with so when it means like the person can, it says the person can swim 1.6 meters in still water.
That's right.
But the river is flowing.
Yeah, flowing.
Like,
yes, that's right.
does that have any?
You
does that have any effect?
You can draw the diagram. What do you mean effect? How many variable?
Like as in, just like it says still water, but the river is flowing. So.
Well, still water is the velocity. Yeah, that is a velocity implies that is relative to water. So you can consider this this velocity is the swimmer relative to water. Okay.
Yeah. Okay. So
because that is what yeah.
So if I have a bank and a bank.
Yeah, two bank.
And
two river. Yeah, yeah. Water is which is direction of water? Which is direction of water?
Direction of water is.
Yeah.
Oh, it doesn't say at the moment, but.
Well, you can assume up or down. You can assume one direction. So can I just draw this? Just well, instead of say water, can we say that a large boat traveling along this direction? This boat, can you see? So this is guy actually watching this boat travel in that direction. Can we see that?
Yeah.
Instead of say swimmer, can we see the people trying to walk across the deck? Okay, the same thing.
Okay.
The same thing. Relative speed is given, but we don't know which direction. Do you see? We know the relative speed is that is only the this could be any direction. So the direction of this let me just draw the point. We don't have to make it too complicated. So we just there's an object moving. We just can we say this object is moving? Okay, at a certain speed, relative to this water, to this boat. Okay. Can we just draw a circle? We don't know direction. We don't know direction. It could be any direction. So this direction of movement could be any direction. But we just consider, can consider this direction, the moving, relative to the boat or relative to the water, the same. If you just think the boat or the train is moving, it's the same story. Okay.
All right.
Now you have to also what is unknown? Swimming around Kansas, swimming across the river. The river length is given, so this distance is given.
I think it's like. So that's the
you want to draw another
flow
diagram?
of the water, and then this is the.
So this distance is given. This is d. This d for distance. Okay, the d is given.
D for distance.
Oh, you just consider the boat is a river. It's the same. You see.
Okay. Yeah, makes sense. So
anything else?
Okay, and the boats.
Yeah.
And
the flow rate is given. Can you see the flow rate is given? Do you know the flow rate? The flow.
Oh,
the flow rate is 1.2 meters between the parallel banks. Parallel banks. So this v is given. So this velocity is given. Can you see? If I write down here, so basically this velocity is given, and also we know the direction. So this is 1.2 meters per second.
Yeah.
Okay, that is another given.
And is this the velocity relative to the water, right?
Yes, that's right. That's right.
Okay. Oh, so that's relative to the water. How far she goes in still water. is relative to the water. Yeah.
Yeah, no. Ask what find the speed of a relative to the riverbank to this guy. So what?
The riverbank is the
yeah,
Earth, right?
it's Earth. Yeah, it's Earth. Yeah.
Yeah. So
Do you remember the
if
method
she's swimming,
did you remember the method I showed you before?
yeah, first you need to think of the
Three
like
objects.
one
Three
equals
objects,
yeah,
right?
one,
You have three objects.
and then you need to give the V1 to 2, 1 and 2, 3 to the objects. You need to denote.
You just insert a third object in between. That's all.
Okay.
Can we just put this problem? Can we call this Earth is one? This object is one. Okay.
Yep. So
the water
Earth
or the boat
one.
is two. Okay.
Yep.
The swimmers or the object, moving object is three. Can we use this notation? Okay, this is very important. Okay, that's how to how the student learn from me. So basically, you have swimmers. We have the swimmers. You have the neighborhood.
Yep.
You have named as three. Okay, and the riverbank is just a bank or the earth. Okay, bank is one. And the water, another thing is water. Okay, you have to make sure you use this notation. This is step one. Step one. Step two, you have to write this formula in question. What is the question given? So they say the velocity of the swimmer relative to the bank to the water is given. Can you see that?
Yeah, we're given that.
That makes sense. That makes sense.
Yeah.
So this is given. This is in vector form. Okay. Now, to be associated with another object, which is riverbank one. So what you do is simple. You just rewrite that as a sum of two vectors.
3, 1.
Now let me finish that. So that's two vectors. And you keep the first subscript and the last subscript, okay?
Yeah.
And then you insert another one. So I use different color. Yeah, I just review. If you still remember, you put it which is unknown. Hang on, that is a one. I'm wrong. Hang on.
It's 2 at the end, right?
Yes, 2 is end. Yeah, this is a 2. Oops, sorry. A little bit of delay from your side. So we put a 2 here, and then put the third object. Third object here. You see?
Here. Yeah.
Where is my 3? This is 3. It is 3. Okay. This method can help you to solve any question related to the relative velocity.
Yeah.
Do you want to go further? Do you want to go further? So what is unknown? So what is the velocity they are looking for?
The velocity of the swimmer relative to the bank.
Yes, that's right. Can we use a vector form? Yes. Can we solve that one from this equation? Can we solve that from this question?
V3 2 plus V2 1.
2 1. Yes. Do we know V2 1?
2 1 is water to the bank. Yeah, it's the flow rate, right?
Yeah.
Flow rate is water to the bank.
So you have to draw the property. So which direction? Which direction is 2 1? You need to draw the diagram.
All right. So
I just
this
how we magnify this? Can we magnify this one? Yes. Oh, good. We can magnify this. Good.
And then V32 is swimmer to the water, which is the girl. V2. Sorry. 3 2.
2 1 is given. Yeah.
Yep. 2 to 1. 3 to actually, if it's so that means.
Are you sure? Are you sure this is right? So what does that mean? So what does that mean? Can we write that? What does this equation mean? What does this equation mean? So you have to, I think, what does this mean? What does this question mean? So you have to use a vector form. So basically 2 vectors. One is 3 1.
Yeah.
Okay. One is a 3 1. 3 1 to be. Can we just go this vector? Can you see? So this is 3 1 equal to the sum of 2 vectors. Okay. 2 vectors is the sum. Okay, not the vectors. You have to draw the property. You have to. This is not right. How to get the sum?
Yeah.
First, you have to find whatever. So you can call this is a. Can we call the V3 2? Okay, that's a swimmer speed relative to the water. okay?
Yeah.
Then according to this one, you have to draw 2, 1. Okay, this is something very interesting. What is 2, 1?
That's the water to the
Water went
bank for the flood.
into the bank. Yeah, went into the bank. Oh, hang on, you changed something. Did you change? Oh, you changed it already. So you change the sign here. You have to reverse this one. Okay. How do you from here to here? You must have done some change. What are they?
Oh, yeah, yeah. No. You're right. I
Don't
should be
memorize.
doing.
Don't. You see, when you solve mathematical problem, follow the logical flow. You don't call your memory. Okay. You have
Actually,
derived.
no, I think
Yeah.
I'm.
Why? You're right. But I just guess you memorize this result.
Oh,
Okay.
it's because this becomes a negative, so you just switch it.
Exactly.
Yeah.
You must know the reason.
Yeah.
You must know the reason.
Yeah.
And write down here. So basically, write down here, make this too crowded here. So that's because first we have, so this is a convention. So that is a V32 equal to V 31 plus V12, okay? And also you can reverse the subscript 31 minus, can you see? That's a 2, 1.
Yeah.
So in this case, 2, 1 is given. Therefore, you solve that 3, 1. Can you see? You solve the 3, 1. So 3, 1 will equal to 2, 3,
3, 2
3, 2 plus and 2, 1. Then if that is the case,
yeah.
Yeah,
That's right. No, that's right. That's
so
should be right.
This is really important. So whenever you shift this, can you use A, B, and if you reverse the BA, this apply, then you have to put a negative sign here.
Yeah.
Okay. So that is important. So then only then this step 2, the step 3 is to draw the diagram based on your graphical method of the sum of 2 vectors. Can you draw this diagram? Can you draw this vector sum?
Yep. Like, so if we use
yeah, that is the first is given. Yeah. We don't need a 2, 1. Why still? Oh, do we need 2, 1? Oh yes, 2, 3.
Yeah, for the sum.
Oh, we need 2, 1, but hang on. If there's 2, 1, yeah, well, yeah, okay, that's fine. What would be the sum? Yeah, that's right. What would be the sum?
The sum is V 3, 1.
Yeah, how to draw that? No, you're not. You're not confident with the graphical method of vector sum and difference. You are not very confident. So we need to review that after that. Okay.
Yeah. Wait, if this is 2 to 1, that's 3 to 2.
Yes, that's correct.
2.
How to find the sum?
But then you just need a. Right, so V. You just have to draw the line between just end.
No. You get the sum? Is this the sum? Is this the sum?
That's my no.
That's different.
Never mind. Yeah. Let me. Yeah, that's right. It's here, right?
Yeah, that would be better. Or you can choose. Actually, you can choose the arrow from the toolbox. You can choose arrow.
What?
You can choose the arrow.
Yeah, you can.
You can choose the arrow. Can I help you? So I choose arrow. Can you see? That's quicker.
Oh, yeah.
So when you draw the vectors, you use this arrow. Yeah. Okay. See,
so that means
this is. Can I just remind you? This is a basic graphical representation of the sum of 2 vectors.
Okay. Yeah.
Alternatively, you can also find the sum by using the second method representation. So alternatively, you can use this vector, and then plus this vector, you have put another vector here, and then you connect the sum.
You can shift it. Oh yeah.
You can connect the 2 vectors from the tail to the end. There are 2 methods to solve the problem.
Yeah.
So both are correct. Okay, but you are not very fluent. Okay, this is correct. This idea that how to work out the sum of two vectors by using the diagonal direction. Okay.
Yeah.
Can you see these two methods are equivalent?
Yeah,
You
I
want
see
to
that.
write down that this is V32 and that will be the V21. Okay. I'm surprised that I'm surprised that both a chemistry teacher and a mathematical teacher, just borrow this problem solving from physics.
Yeah, well,
Well,
it is physics.
well, that's right. If that is the case, why don't they teach you, in physics in the first place?
Yeah, I mean,
Yeah.
I think it's sort of like assumed knowledge. Like they told most of the kids what mg. They said you need to use mg, but most kids didn't know what mg was.
Well,
But,
if you have any idea about the physics, nobody know. You wouldn't expect a student. Anyway, can we go to B? Find the time that takes her to across the river.
Yep. So
we know the speed.
So you know that.
Mm-hmm.
Yeah. So I think it's the speed of the swimmer relative to the bank.
Yes, that's a physics problem too.
Yeah. Oh yeah. So this is 1.6, 1.2.
That's right.
And then to find that
at angle, yes.
Yep. You could just use Pythagoras to find out the rate,
the velocity,
like the speed.
Yes, velocity.
Velocity. Yeah.
Yes, certainly you can.
Yep. And
but
then
how about they are looking for the time? What is the time? So here they are looking for the time. What is the time is? So what is the time? They are looking for the time.
First, you need to calculate the distance first, and then
yes, time. What is time formula? What is the formula for time? In terms of velocity
time
and
equals
distance.
Distance over speed over velocity.
So did you say? Can you write it down? So time equal to what? Time equal to distance.
Distance over velocity.
Over velocity. Yes, you can say so. Yeah, that's right. Yeah, that is yeah, that's right. Do we know velocity? Yeah, we can calculate the velocity. This velocity is 3.1. Can you see? It is 3.1.
Yeah.
Okay. But do we know S?
We don't know S. We know the S for V32, but that's it.
Yeah, we know this side. They actually a similar triangle. Do you see? If this is velocity, if that is velocity, the distance also will form the similar triangle.
Similar triangle. That's fair. Yeah, you could use ratios to figure. What do you call it? Sorry, figure it out.
Yeah, you need to find the angle, right? We do also need to find angle. Do you want to try? You want to stop here? You want to?
Oh, we can keep going with this. So first of all, we could figure out V31, like it's equal to 1.6 squared.
Isn't it a bit crowded? Can we just go to the whiteboard? Can we go to whiteboard?
Yeah.
It is a. It's like a.
So I was.
Is a sketch. This sketch is not proper. Can we go to whiteboard to write it properly? So, the problem is not complicated, but if you make this drawing so can we just redraw that diagram, right? Redraw this diagram.
Yep.
So basically, what we have is this. You just follow your notation. So you got river moving downwards. River moving downwards.
Yep. And then you've got.
So basically, when I draw the river, we just simplify regional, find the regional. You see, so got the two velocities. So one velocity, we just draw the velocity with proper color. So that velocity is the velocity of the swimmer relative to the water, right?
Yep.
And another velocity is the velocity of water. Another velocity is water relative to the ground. So we eventually find out that the velocity of the swimmer relative to the ground is this direction. You see this direction?
Yeah.
okay? But you can argue that because the direction is given, you can argue that the distance, the related distance also form a similar triangle, you see. So this angle must be similar. So if you draw the triangle here, and this triangle must be, let's draw that. So that's distance given. So if, what's going on here? So that would be triangle here, right?
Yeah.
So basically in this question, then the two, just put here, can we say that this is given? Yeah, that's right angle, yeah. You can write from your side, no problem. So we know the distance here, right? So basically they need to find this distance first. Can we call it ABC? Can we just go AB? Can we just ABC? Or can we just go ABC to simplify this one? Probably can. So can we call this, this is A, this is B, this is C, okay? So in the question B, we can solve that at time, but you have to go to, can you argue this first? Because velocity equal to the distance, C over T, okay? Therefore, the time will equal to C divided by V, okay? C will be, in this case, C will equal to that velocity C.
I can solve time first.
Yeah,
that's
it's not C, so this is a how? Yes, we have to work out velocity where the velocity is given by this is Pythagoras rule, right? Two velocity squared. Yeah.
Yep.
Okay, the third one. Right. Yeah, the third one. Yeah, okay. Yeah. Do you want to put a number
1.
here?
1.6
square. Yeah. That's right.
V equals 2 meters per second.
That's correct. Oh, it's integer. I'm surprised. It's integer. But that matter is just by calculating.
Yeah.
How about the second? How about the last question?
Yeah.
So in this question, you need to find what A is. Okay, you need to find A. What A is. In this case, you need to find. How? Yes, we do. Yeah, we need to find A. So in this case, we have to find A. How to define? By the way, how to determine C?
Oh, C would just be so.
How do you determine C?
48.
Yeah, that's 1 point
and 1.2.
1.2.
Yeah, that's 1.2 here. Yep, that's 1.2.
Just put it properly here. This is 1.6. This is 1.6. This is 1.2, right? Or 6.2. Is 6.2? Or just 0.6. Just 6. Just 6. Okay.
Yeah.
All right. That just helps. In this case, be careful. The C is the distance. That is a smaller triangle. C is the size of large triangle. Okay.
Yeah.
So this is velocity. This side is velocity 3.1. Do you remember? It's velocity 1.
Yeah.
Oh, it happened to be 2.
So that means.
Lucky. Yeah, it's good. Yeah.
Yeah. So C. So 48. 8 over 1.6.
Similar triangle, yeah. Similar triangle, yeah.
Yep.
Yes, okay, that's fine. No problem. How about A? Similarly, how about A?
Meters. So we need to, what are we trying to figure out?
In meters. Oh, this side. How about the distance? Can you return to your question? Can you read your question? The question asks, what is the distance of this side?
Yeah.
Along the river.
The position at tribes on the opposite bank.
Yes.
Yeah.
So that's right. It's opposite bank. So there's observer here that's swimming, just trying to swim. It's an attempt to swim over that, but actually, because of water is moving,
then
so therefore he will
push down.
She can't land it here. They have to land it somewhere here. Right. So what is A?
Well, A squared equals 60 squared minus. Then
48. Yeah, that's right.
60.
Yeah, simple. Any other question? We only solved 2 questions today.
Square root.
Number is insignificant.
That's it. Those.
Okay. Number is not important.
Yeah.
The importance you have to remember this. B and C are relatively simple. Yeah. Okay. The important thing you probably have to remember Can we probably, because emphasize, I don't want to miss any mark for this type of question. So step one.
Yeah.
Step one is to denote the three object
Yeah.
in question.
Yeah.
This is just mechanical, and you will never make a mistake. Okay. For example, just this is a swimmers. That's called three. Okay. A bank. It could be airplane. Okay. Could be ship. Could be bird. Could be anything. See. So, but one thing is certain that you have used a three number to represent this bank. So now the bank is one. Usually they also call this Earth. Bank is also called Earth.
Earth, yeah.
When they have the question, when they say swimming, if they didn't indicate relate to what object, they often imply, as your text said, they often imply this is velocity relative to Earth. Okay.
Yeah.
For example, giving the airplane, the velocity equal to 50k, okay, meters per second. So what is this velocity?
Is that, well, it doesn't say relative to the
If you didn't say anything,
air.
what does it mean? So yeah, if you said given to air, so if have this is a ground, so this is a ground, is Earth, is a ground or ground, this Earth. So this airplane. If this says the velocity, what is the velocity? What is the velocity they refer?
Of the airplane relative to the Earth.
That's right. That's right.
Yeah.
That's right. So
sometimes.
The water, yeah.
Sometimes it says, like ground speed. That's relative to the Earth, right? Because it's the.
Yeah. But if you don't say anything, that's just relative. So for example, this is example one. This is very important. Example two, because airplane. So airplane. Sometimes we need to summary, okay? Need to be to summary. So it could be air. So air is moving. You say the air is moving, and the water is moving. The air is moving, right? And that is the ground or Earth. Because you have to also put it 3, 2, 1. Okay. So basically, what does it mean? This velocity for airplane. If this is velocity, and then you have to immediately assume. Actually, your textbook have told you that if you check your textbook.
Yeah.
It says that if you didn't mention any particular reference, then that means that the velocity in this case is 3 to 1. Okay, 3 to 1.
Yeah.
All right. Now step two is to rewrite to add the missing
vectors. Yeah.
Yeah, missing vector. Yes, the missing vector. In this case, velocity. Okay.
Okay.
So for example, if you have, say, if you know that the velocity 1, 2, what can you do? You just rewrite the two vectors. Okay, two vectors, one here and two at the end.
One
and you put
then two at the end.
Third one. You put the third one. Can you see? That is a very reliable way to do. Of course, the step 3 is just use the knowledge of how to draw the sum. Don't forget the same thing. You see, when you have sum, then you just found the diagonal. That is a first. This is basically starting point. Alternatively, you can just find the sum by just rearrange these two vectors, and in order to find the sum. That is an alternative way. There are two ways to find the vector sum. Okay, I hope that will help you to solve this type of question.
Oh yeah, that's helpful. I looked so yeah, it was just that I was looking at the chapter review, and this was pretty much the only question. There's other questions on like forces and stuff, which I got. Those weren't as hard, and it was just that question in the practice test. So the test is actually on Wednesday, not tomorrow.
Okay.
Yeah.
Well, you
so
see, we still have 1 day. So basically, to solve the force problem, you need to to follow this step. You see, remember. Do you remember now? I don't have to write. Number 1, to draw a free diagram.
Free
Okay.
body diagram.
Free
Yeah.
body diagram to edit all forces there in the
And
vector
draw the
form.
plane. Yeah.
No, then choose a coordinate. You
Yeah.
choose a
Then choose.
coordinate.
Okay. Yeah. Yeah.
And then find the x and y components and zero
Yeah.
them and zero them.
And
And
then
then solve the algebra equations.
solve. Yeah.
So if you know these general strategies, then you have no trouble
Yeah.
to solve problem. Okay, shall we stop here now?
Oh yeah. All right.
See
All right.
you
Then thanks.
tomorrow.
I'll see you tomorrow.
Okay.
All right. Bye.
Goodbye.